Alright, so let's get started. Where was I? I guess I was done with creating and then destroying. When we have this function, the most important that is responsible for finding as well as creating a new bucket, right? Okay. Key value pair. I think I know, we just insert keys, right, and traverse. Okay, then we have a function to traverse the node. Okay. Read count. Yeah, okay. So I was like, I must know what does the read count suggest here. If read count isn't 0, then we return RC. Okay, so read count should be 0. Let me take traverse good. Okay, so this is a function. Traverse where we got traverse call. We have a global. We have a global variable called traverse called, and we're going traverse called. Then we increment it, okay, and we display the data, okay, in the key. So we are only displaying the key, right? Right, so then this is traverse fail callback. Traverse called, then we check if traverse called is 2, then we return 1, else return 0. Okay, so the return code 0 means it has traversed successfully. Return, right? Return code 0 means it has traversed successfully. Hash map, is there a traverse function? Okay, there we go, traverse. Okay, so you have to provide hash map traverse cb have I defined. Okay, there we go. This is the function for traversing the node and displaying all the data associated with that. Okay. This is a user defined function which tells how to display the data within the node. Okay, alright, so we enter the buckets. Check if the bucket is valid, that is, if it contains any data, okay, any data which equals 0 and j less than DRA count bucket. Okay, we get the node and we traverse it. Fetches the node and traverses it. Okay. So any value other than 0 is considered an error. So I think the documentation part is done, right? Okay, this assumes that all the keys are unique. Here we traverse, all the keys are unique. Here we traverse the DRA which is provided and compare. Okay, so I have to perform some security measures. Compare, right? Okay, so hash map, if map, we check if the map is valid. We check if the bucket is valid, right? And we destroy and free them. Okay, then we go a function to create a hash map. So we have starting in line. Okay, so hash key void, as simple as it gets. Okay, but I think we should check key, but null is also valid, null is also valid, 0. Okay, so null key is also valid. Starting in line DRA hash map. Okay, first check the map, check map not equal to null, error, invalid map, right? And then we have to check that these two function, okay, also make sure that the types of both the values is same, else compiler will throw an error as they would have different memory layouts. Okay, then we don't need to check the bucket here. Okay, we check the map again, check map, error, invalid map, set. Okay, and we fetch the node, yes, check the bucket, okay. Check bucket, error can't create bucket. Okay, now we simply, okay, so we check mem node before pushing it into the, right. I hope I have checked the memory on the bucket before pushing it, right? Okay, so we got declare bucket before using it. Okay, bucket and node. Then we have get, right? So we go through the bucket and we search it. DRA get bucket of I node hash map, right? Okay. And void hash map underscore get assign int 32 hash used for finding the node. DRA bucket hash map find bucket, if not bucket return null, right? Okay, then we have entire hash map get return null, we check the node and then we return the data. Alright, traverse is bucket, and I should also check, okay, then I should also check if not node, then we return 0. Sorry, traverse node, return 1, right? Node 0 return RC, check for valid node. We have a valid bucket. I should check the map, check map not equals to null, error, invalid map. Then I can just go ahead and throw an error, return 1. So I can put check mem, okay, check node if not equals to null, say error, invalid node. Check for valid node, RC traverse, right? Okay. The function map dear bucket hash map find bucket. Okay, we don't want to create it with the key, if not bucket return null. Okay, then we find the node itself, right? Then we get that node from the bucket. We get the node, we store the data and we free the node. Okay, now we fetch the node at the ending, then we check if both nodes are same. else we swap them. Okay, so this is done. All right, let's go to tests. Okay, so we create a bunch of values. We have a hash map, uh, a traverse called function, a traverse called a global variable called traverse called, then tag b string test1 test will be a static. So these are strings, these are keys and these are values. Okay, traverse called equals to return 1. Okay, let's create. We create the function null, so it creates the default function. And then get set. Okay, so we set the addresses of these, right? Address void pointer. Okay, so just this is the key, right? Hash map function, hash map set, hash map create default. Okay, so the default hash function returns, and default hash takes a b string. Okay, so we'll get address of a b string, since tag string is a since b string is actually pointed to a tag b string. Okay, I feel like alright, since b string is actually pointed to tag b string, if we provide their addresses, it is equivalent. If we provide the addresses, it is equivalent to passing a p string. Okay, so we set these values, then we p string result, right? P string result equals to map test1, and result should be equal to address of. Okay, so it will return me an address. Okay, returns the void pointer, that is the address, and b string should, right? Okay, then we have maps, we have traverse. Okay, so we have traverse good. Okay, so traverse called equals 3. Okay, map, and then we go traverse good, traverse called. Does it print anything? Debug. Okay, do I have the debug flag on? I don't believe so, but let's try. Make okay, so there we go. I get the function key. Okay, so we get key b string, b data, it's a b string, and then node and key. Okay, we made it in the form of b string. Okay, so test data 3, test data 2. Okay, traverse called should be 3. Okay, so right, traverse called, then we reset the traverse failed archive equals 1. It should be 1, or else it says failed to traverse, round count traverse for failed, and traverse called equals to, okay, so traverse called should be equals to 2, right? Okay, so we are basically checking when we provide this, it should return a 1 and traverse called should be 2. So we are making sure we get both the values here, right? Okay, b string deleted equals, we map it, delete and map test1. We should delete it, should not be equal null, and it should have the same address, and result hash map get, and we should get a null. Okay, so we are basically checking on. All right, so that is it for the understanding. Right, so let's see what else we can do. Alright, so let me take a look at the book, and then we'll sorting. Okay, hash maps, hash, then I should bring a hash map if you want, setting key values, finding bucket. So there's nothing very complicated in the implementation, but the default hash and hash find bucket. Okay, hash find bucket function will need some explanation. When you use hash map create, you can pass in any compare and hash function you want, but if you don't, it uses the default compare and default functions. The first thing to look at is how default hash does its thing. There is a simple function called Jenkins hash after Bob Jenkins. I got the algorithm from Jenkins hash page on Wikipedia. It simply goes through each byte of the key to a key to hash a b string, and then it works the bits so that the end result is a unsigned int 32-bit. It does the same thing with adding the exclusive OR operation. There are many different hash functions, all with different properties, but once you have one, you need a way to use it to find right buckets. Okay. The hash find bucket does it like this. It calls map hash key to get the hash for the key. It then finds the bucket using hash modulus default number of buckets. So every hash will always find some bucket no matter how big it is. Okay. It then gets the bucket, which is also a D array, and if it's not there, it will create the bucket. However, that depends if the create variable says to do so. Once it has found the D array bucket for the right hash, it returns it, and the hash out variable is used to give the caller the hash that was found. All of the other functions then use hash map find bucket to their work. Setting a key dash value involves finding the bucket, but making a hash map node and then adding it to bucket. Okay, getting a key involves finding the bucket and then finding the hash map node that matches the hash and the key that you want. Okay. So okay, because different keys can generate the same hash. Can they generate a hash? I don't know, but we still check it. Okay. Deleting an item finds the bucket, finds where the requested node is, and then removes it by swapping the last node into its place. Okay. The only other function that you should study is the hash map traverse. This simply walks through every bucket, and then for any bucket that has possible values, it calls a traverse callback on each value. This is how you can scan a whole hash map for its values. Okay, then we write down little. Okay, the only thing to learn about this unit test is that at the top I use a feature of bstring to create static strings to work within the test. I use the tag bstring and bstatic to create them on line 7 through. Okay, how to improve it? This is a very simple implementation of hash map, as are most of other data structures in this book. My goal isn't to give you insanely great, hyper-speed, well-tuned data structures. Usually those are much too complicated to discuss and only distracts you from real basic data structure at work. My goal is to give you an understandable starting point to then improve upon or better understand the implementation. In this case, there are some things you can do with this implementation. Okay, you can sort. Okay, you can sort. Right, so you can sort. You can use a sort on each bucket so that they're always sto- so that they're always sorted. This increases your insert time but decreases your find time, because you can then use a binary search to find each node. Okay, right now it's looping through all the nodes in a bucket just to find one. You can dynamically size the number of buckets, or let the caller specify the number for each hash map created. Okay, so we can add these. Okay, so I'll start with go I'll name it improvements. First is sort sort the okay to sort each of the bucket. Okay, alright, so sort each of the bucket, I hope, in the D array. Sorting and searching. Okay, advantages and disadvantages. Improve the unit test to go more operation than using for loop and show it such they would take implement rules or answer. Okay, some performance. Okay. Look at how DRA expand is implemented in constant size. Typically, dynamic is implemented multiplicative index size into 2. But I found this to cost needless memory for no real performance. Can you test my session? See, okay. Sort each of the bucket so that we can use binary search. Okay, sort each of the buckets so that we can use binary search. So we can use binary search to find the elements. This would increase insertion time but decreases okay, insertion time but decreases the searching time. Okay, decrease the searching time, since currently it uses linear search to find the keys. Okay, then alright, so to find the keys. Okay, so I think I would need to include the D array algos, right? So make W clear. So I think I will dynamic sorting and searching source. Let me take a look at. I think I would in a sense need all of these. So I can open these with this. Okay, so we have these D array. Okay, so it is D array algos. I have some functions I have provided. The array algos will use the option for sorting the array. Okay, so I have a function, instead of function, the array find, the array add sort, and I can provide a sorting mechanism. Okay, so pq.c. Okay, close on. Right, so and dynamic array source. Yeah, so now we're not validating the access for this index, so let's do it. Original code modified version. And I have this. And insert. Service directory set is currently running. Let's set up please set okay, whatever. Alright, so right, so will take these and I'll replace them here. Just replace, and then also I would say sorting does okay, Redux map doesn't use us. Okay, so priority queues source, do I define right, so okay, static array we don't necessarily have pointers and therefore we show that this is the feature of the element. Okay, function definition for declaration. Bubble up, we will compare the parent of the current element with itself, and if the parent is not dominant then we swap. Use root. Swap and call the function again with updated syntax. Okay. Okay, so another thing that I noticed was let me go sorting and searching. Source, let's see, hardware, PQ. Okay, is this the updated list, or is it the old one? It should have list merge. No, I think I defined those functions, list merge and clear destroy first last, linked list algorithms, source list algos. Oh, okay. So let me open them. Okay, so we have list, there we go, list split and list merge. Okay, so I went list split, so I have this unsigned int position split. Okay, so I made any changes? No. Okay, list first list is empty. Let's can't split a single element list, and then position not 0 and end position is an invalid position. Get the list pointer, then linear traversal up to specified position. Okay, split. I'll be creating a new list, updating the list. let's create, then updating the list and updating the first and last the new list, right? Okay. So we are updating first and last of the new list, updating the last of the original list. Okay, so new list. Okay, new list, list first, list of last, last equals the new node. Okay, list merge. Okay, in order to merge the two lists, we can take into account the factor such as updating the end. Okay, hold up, I don't linear traversal up to the specified point. Position, okay. Then we go create a new list, updating the first and last of the new list. Okay, this is the new list. So new list first equals node dash next. Node null. Node equals current. Okay. Oh, okay. That is the position up to the. Okay, node position. If pause equals position defined, we get the. We want to split at that position. Okay. New list first of previous equals null. New list equals last is list of last. Okay, so we have just splitted. So we are basically splitting it x and choose option. If we choose position 2, that means I would need to split at the end of 2. Okay, at the end of 2. So if I reach this position, so we will split from here as is specified. Updating the last of the original list. Okay. So updating the count of both the lists. New list of count equals list underscore count and list of count equals position. All right, and it returns a new list. So source list and destination list, and it merges it into the source list. I hope, right? Okay, so attach the last of the source list to the first of the destination list. Source dash last dash next equals, right? Okay, merging and list algos. There was bubble sort. Okay, so sorted. Just continually swap. Then we have a function for merge sort. Okay, so we take this, right? We go up to hash maps, source, we paste this. Then I think I updated these, right? I should say 36 create function resize, right? Okay, great. Then I need the sorting and searching. So I need these algos along with PQ and PC. So I have move up to source. We paste all these. Alright. So the first thing I want to do is sort, right? So I would need to include the hardware DRA, I think algos.h if I'm not right, and okay, shift P, we build tags. Okay, hold up, I should go here, shift P, we build tags. be preferences, these all open for. Okay, so I finally have the array algos, right? Okay, so I want to add a function. I want to include the array algos header file. Okay, so I have latest hash map. Insert, can you search? Okay, so when we set the values, right? So when we set the values, here. Okay, hold up, I can. There we go. Hash map set. There we go. Then push, right? But instead of push, I want to. Okay, I want to look into Alt S. Let me see. Sort add. Isn't there? Okay, not in the file. I think control. What is Control Shift S? Okay, and also add. Yeah, sort add. Where is this function? darray underscore sort add, right? So it pushes and then it sorts the array. So I want that functionality, so I'll go darray sort add, right? Darray sort underscore add, we provide the darray, then we provide the I think it has a default compare. I can just the element, so I set. Okay, so within the set functionality, sort add and reference. There we go. Okay, so we take the element, so it takes the darray, right? So it takes the darray, it takes the element, not right, darray, it takes the element, then it takes the compare function, so which is I think darray compare. So I can provide darray compare with I think map. Can't find map. Sorry, hash map. Hash map dot h compare. So I can go map dash compare. Right. So I can go map dash compare. Okay, I should really go improvement, original code, simply we were pushing, right? Simply we go darray push, right? Push bucket and node. Let me tab it by one. Okay, improvement, adds by sorting the data. Okay, compare. I would need to define a hash node compare, right, function. I think I would have to define hash map compare, pointer to function for comparing keys, right. Hash map compare should be const void a, const void b, hash map compare. Okay, let me take a look at default compare, right. We go b string of a, then b string of b. Okay, and it uses this compare function in node, right. But I'm not comparing the keys, I'm comparing the nodes themselves, right. So I would need to define a function default compare function for nodes, which internally compares the let's say which internally compares the p strings. So I go static and default node compare const void the pointer of type so I would need to set this is compare pointer to a function for comparing keys, right, and comparing nodes. But okay, I can use this compare, right, internally use this compare starting and default compare function for nodes which internally compare the b strings. Okay. So const void a const hash, okay, hash node, what is it called, hash map node, okay. Hash map node a const hash map node b, then I want to return default compare of a dash key comma b dash key. Yep, okay. So this is the default compare. Hash map set, there we go, hash map set. So DRA compare, looking for default node compare, right, default node compare, default node compare, right. Okay. So default node compare, but I haven't no, I can pass this function, yeah, okay, that's okay. Pass this function, and then finally okay, and finally I need algo sort. Okay, let me see, where is it defined? Tsort algo? Nope, it is not defined. Okay, let me array. Okay, so there we go. Heap sort, merge sort, I'll go with. Let me take a look at definition. Okay, heap sort. So I'll go with heap sort. Is that right? Okay, heap sort too. So here is sort, and I'll pass in array heap sort. Array heap sort. I think this should work now. Let's check. Make okay, conflicting types list merge. Alright, so I think I should copy the list merge which was defined here. Okay, list, yeah, okay, so, and let's try it again. Right, source, replace this files. Let's try make clean W and then make it again. Okay, so everything works absolutely great. Alright, now hashmap get, right? Okay, so this is the original code. Hashmap get I think I have defined a function called find array find. There we go. Okay, so we need the array element and the compare function, and it returns. Okay, I want it to return the index. Okay, so array find array algos, array find. Okay, so it returns albeit I think it should return the index. So state the function now returns an index. Now the function now returns an index to the element in the array, right? There's definition here. Okay, how? Okay, F12 is definitions, right? And shift F12 is references, right? Shift F12. Okay. Void, right? The array algos, I think these should be here. Okay, so let me just update this. Int, okay, int middle, and I think I should simply return middle and return -1. Okay, can't check if L is null, as it may be 0 in the case of integers, and it will throw an error. Okay, so array count use this and we return the middle index. Okay, so that is great. Now let's say t array find. What am I finding? I have to, okay, so first I have to compare the, okay, t array compare, the compare function default compare. Let's see it for default compare, so I'll cast it. Find, do I provide okay, hold up, get node, right? So so we have the hash, we have the bucket, and if I have to find, okay, if we pass in the element that we want to find, but I think yeah, but basically we do pass in the element that we want to find. Okay, so how can I pass in the element? I have the hash, I have the key, and I have the bucket. Okay, so how can I change it so that we get the, okay, how can I use the array find, because currently it will look for, right, the array get hmm hmm how can I have node return I, right? Okay, yeah, so I have to search on the bucket. This is I'll say is original code. Okay. I want to get the updated. Okay, so we are looking for hash. Okay. Can I get the definition? Where is it being used? Hash map 250. Okay, hash map get node. In the hash map. Okay, hold up. Hash map C. Hash map find bucket. Okay, so find bucket, we provide the map, key, and hash. Okay, so we want to find hash map find bucket. Okay, hash map find bucket, right? Hash map find bucket. Okay, so we generate the hash map find bucket. So I don't think I was hash map set, right? I was on hash map get. Yeah, hash map get node. Okay. So this is in that all the keys. Here we traverse the array which is provided and compare the keys and hash values and simply return index to the element in the array at the end, and Okay, how about I generate, right, ideas, okay, ideas. How about I create a new node with the same hash key values and then search it within the array. Right, so I'll go hash map node equals, let me go to the definition. Okay, so we have a key, a data, and a hash. Okay, so I don't need the data part, I'll just go with the key and hash. Okay, so I'll go dot key equals, maybe I'll provide it in this anyway, data is null and hash is hash. Okay, then we pass this element, into DArray find, element to DArray find function, right, and it will compare, right. Okay, so we go say int r equals DArray find, within the bucket I want to find node and I will give it that function DArray compare. Compare, default compare, right. Default compare, where is default compare? No, okay, shift S, compare, hash map compare, default compare, hash map compare, default compare, hash map compare. Ooh, can't find default compare. Okay, oh yeah, sorry, I would need to shift P, rebuild tags. Okay, now we go to compare default. Okay, so it was default node compare, default node compare, and do I have any other DArray find? That is all right. Okay, node and the compare function, then I can simply return R, right. Map node, map node, creating on the fly. Okay, right, DArray compare. So I just want to make sure this function works, like, okay, so we'll go, then we'll compare DArray compare, and its results, if it finds the key and the hash should also be equal, so I should add this. Okay, compare default compare, okay. I'll check if default compare equals 0, if default compare equals 0, then and okay, and hash, right, okay, a hash, because I believe that it contains a hash, right? Yeah, so it contains a dot hash equals b dash hash. Only then can we return a 0. Else we simply return the same default compare a dash key comma b dash key. Okay, I want to make sure that the new version of default compare works, right? Okay, new version of default compare works. So let me go to, where was I don't even remember which function was I. Yeah, okay, this. So updated, maybe we can just want to make sure that it does not break -1 code. It does not break any functionality, right? Okay. So ooh, okay, undeclared, right? Unknown type, original code. Oh, my bad. Then we go make right, okay, int I and DRA find, oh yeah, DRA get bucket of I. And everything works. Okay, so I think what I can do is, since this works as is, right, DRA node compare, and I can go return R, because it now returns the index, right? And if not index, then it returns the -1, which is equivalent anyways. So I can go check and make it again, and let's see if everything works. Yep, everything works the way. So this has been implemented. Okay, so I am done with files, and use the required functions. Improvement 1 done. Right, so we can call it a day today.